Okay, in this question they ask you to find the smallest angle in the triangle shown. So the smallest angle is always opposite the smallest side. So you just find the smallest side. So in this case, 15 is the lowest or smallest side. So A must be the smallest angle. So that's one we're going to find out. So if we label up our triangle like we normally would, so I'm going to call this little A, this little C, and this would be B, I need to find angle A. So I have, I could use a number of formulas. You might use one or the other, but because I have the two sides and the included, and I want that included angle, I'm going to use the cosine rule. Okay, so the cosine rule for A is when we use cos inverse, we use all the sides. So I've looked up the formula and this is it. So if I go and plug in all the data for that, it will be b squared, which I've got is 23 squared plus 17 squared, minus A, which is 15 squared over 2 times 23 times 17. And then you can type that into your calculator. Okay, and it's set to one decimal place, so I got 40.7 degrees. So you might have had your rule like this, or you might just have n solve, and you might have had cos A equals, and you had that formula like that, and that's fine, you can do that too. And use n solve on your calculator and go comma A. That's alright too, you'll get the same thing. Alright, so let's do this one. The pennant flag is to have the dimensions shown. What's the area of the cloth needed for the flag? So they pretty much just want the area of this triangle. If you look at your formulas for area of a triangle, there's only one that has an angle, and that's the sine rule. So if I label up this A, B, and C, and then call this little a, little b, little c, I'm going to use the area formula that has the angle A in it, because that's what I've got. So I would substitute in half times 60 times 60 times sine 25, and off I go and do that on the calculator. So it said to correct to one decimal place, so I've got 760.7 and can I say centimeters squared because it is area. And there's that one. Okay, one group of bushwalkers left a road running north-south to walk along at a bearing of 60 degrees. So what this is, we need to set up the scenario. So remember what I said about, put your little compass bearing. So they set about on a road that walked north-south. So that's pretty much saying let's get our little compass ready. And we're going to say they started here. So here's start. They walked north-south. So they're going down on a bearing, well, that's where they start, and they go 60 degrees. So they've left off here, and they're saying they're walking out here, and that is 60 degrees. A second group of walkers left the road from a point 3 kilometers north. So they're up here. They've gone 3 kilometers, but they're going to leave from here, and they left on a bearing of 120. So if you think about theirs, 110 would be somewhere out here. So the second group to point C, the two groups met. So say like that's 110. I'm going to say here's the second group went out there and they met at point C. So I've got point C. Now they told me that this was 110. So to there is 90. So this little bit in here must be 20 degrees. If that's 20, then this bit in here must be 70. So you know that. Find the angle at which their paths meet. So this first question A is there, I would say. So if I drew this triangle out a little bit separate, I'm going to call this group A. Here's B and C. I know that's 3 kilometers. I know that's 70 degrees. I know this is 60 degrees. And at the moment they're trying to find X. So that all the angles of a triangle have to add up to 180. So 180 minus 70 plus 60. So that equals 50 degrees. So this one, so X must equal 50 degrees. So I'm going to say that. Find the distance. Now the second part of the question is find the distance that they walked by each group corrected 2 decimal places. So that means the first group walked that bit and the second group walked that bit. So you're going to have to do 2 different calculations. And if I looked at this triangle, that'd be little a, little b, little c. I've got to find little a and little b. Now remember, we know this is 50 degrees now. So I might use the sine rule to find them, because I have both the pieces of data for C. So I'm going to say C over sine C equals, and I'm going to find A over sine A. So I'll do that first. So little c is 3 kilometers, angle C is 50. A I'm trying to find, but sine A I know is 60 because I've already worked that out. So then we can pop that in NSolve and comma A and find that. Okay, I find A to be, and they said 2 decimal places, so I find A to be 3.39 kilometers, and then I'm going to do the same scenario, but I'm going to use this time B because I want to find that distance B. So if I plug that all in, once again, it'll be that. B is what I want to know, but I do know angle B, which is 70, and I can pop that again into solve, comma B, and I'll get B to equal 3.7, oh no, I was 2 decimal places, sorry, so 3.68 kilometers was B. Okay, and the last part of the question, might do it in green so you can see. If the bushwalkers decide to return to the road by walking along the path that the second group of walkers has taken, what bearing should they say? So they're going to go along that path here that I'm just going over in green, and if you're starting from, they're all sitting at C, so I would draw, I would put my little compass in on C. So what you've got to do is you have to find the angle that goes from the north all the way around till it hits there. So it is getting a little bit messy, so I'm going to draw it up again on the next page. Hold on a sec. Okay, so I'm just drawing it up again here, and there was a couple of pieces of information we knew. We knew originally that the first group went out on an angle of 60, so you know that's 60. So remember, we want to go from where they are, they're all at C, and they want to go back along this they want to walk back there. So they're saying, what is that direction from C? So I have to start at north to C and go all the way around. So that's the angle they're trying to find. You're trying to find. Now, if you look at the north lines, they act as parallel lines. So you can see you've got north line there, and there's also a north line there. So we knew that this that when B left the group, that was 110. If that's 110, then this is 110 due to parallel lines. So if you know this little bit is 110, you just have to add the straight line bit, which is 180. So the bearing of B from C, that's what they're asking, is equal to the 180 plus that 110 degrees, which is going to be 290 degrees true. Okay, the last one, a yacht left a port and sailed 45 kilometers on a bearing of 290. So a yacht P, so I'm going to start with a compass in nice faint writing, and then I'm going to start, this is my P, the yacht starts, and it travels on a bearing 45 and a bearing of 290. So 290 would be there to there is 180, 270, so 290 is somewhere out here. So we're going to say they went out along there to another point, and they told me that was 45 degrees. Now, if you know that bit all the way around there was 290, you know to here is 270, so you definitely know that this little bit in here must be 20 degrees, just things that might help later. Another yacht left the same port and sailed 54 kilometers on a bearing of 40 kilometers. Sorry, we should probably say that was yacht P out there, and maybe just call this bit the start. I'll just call that the start. Okay, so yacht P went out on 40 degrees. So 40 degrees going from the north. Remember, that's 90, so it must be somewhere like out here. And they went for, were they 54 kilometers? So I might draw that. So out went Q to Q, and they went 54 kilometers. And they went on a bearing of 40 degrees. So I know this bit in here is 40 degrees. Alright, so there's a few things also that you know. If we go back to that first group, and because they went 290, well, you know that to do a full circle is 360, so you know that in here is 70. So that's going to help us work out, because now I can start to draw a triangle that looks like this. So this was the start, this is where P is, and this is where Q is. And if I add those two angles, which I have 70 and 40, I know that this must be 110 in there. Also know that this is 45 and this one's 54. Alright, so what is the angle between their directions? We just worked that out. Is 110. And how far apart are they at this stage? So this question here is pretty much that one there. So if I label this triangle up like we normally do, A, B, C, and this becomes little a, little c, little b, I want to find little a, and I've got two sides and the included angle, so I'd use the sine rule. So that's where b squared plus c squared minus 2bc cos a. So I write out what I know. A is what I want to know. b I know is 45 squared plus 54 squared minus 2 times 45 times 54 times cos 110. And then you can just do solve in that and comma c. So if we do that, so I get a to equal 81 point, and it said 2 decimal places, so 2, 6, and it was kilometers originally. So I'd answer that with 81.26 kilometers apart. And that seems pretty reasonable. They look like they'd be further apart than the other sides, so it doesn't look too off. I'm pretty happy with that.